Introduction. The kinetic theory of gases as a good physical interpretation of the motion of individual molecules in fluids. There are three kinds of molecular transport or molecular diffusion. The first is momentum transport and Newton's law. The second is heat transport and Faraday's law. And the third is mass transport and Fick's law. Transport process molecular one dimension. Application from general properties of cell balance. Momentum transport. The law of cell balance. For general is for steady state is for constant area is and for steady state and constant area is. Steps to solve the problem of cell momentum balance. 1. Draw the picture of the system and give the coordinate axis. 2. Apply the cell momentum balance. Then we have the differential equation in dependent variable. 3. Solve the differential equation that we had from step 1 and 2. 4. Use the Newton law to relate with flow rate variable. Then we have dependent flow rate variable. 5. Solve differential equation and make boundary condition to solve the constant integration. The boundary condition. The boundary condition between fluid and solid surface. Assumption no slip condition or zero. The boundary condition between fluid and gas. Assumption no shear stress or zero. The boundary condition in surface fluid for two fluid with not mixture is the distribution of flow rate and shear stress continue. For surface, axis and symmetrical point is no shear stress or zero. The example: Newton fluid flow in a pipe. The condition is steady state and laminar flow rate. Determine A. The flow rate distribution of fluid. B. The formulation of flow rate volumetric of fluid. This is the figure. Solution. For this equation, in steady state condition, we have this equation. We also know that this equation and we relate for above equation, so we have this equation. To relate equation of two stage, we have equation. To solve this equation, we must use the boundary condition. And the boundary condition is, we relate the equation for boundary condition and we have this equation. We know that tau xj is, and we relate for side of equation and we get this equation. Next, for this equation, we must use the boundary condition 2. The boundary condition 2 is, and we relate the boundary condition for this equation. So we have this equation. The equation of K2, we will get this equation, and we integral of this equation, so we have this equation. The answer for A the flow rate distribution of fluid is P. The formulation flow rate volumetric of fluid is. Thanks for your attention.